We're going to take a look now at some of the word problems that we are going over, and it is using systems of equations as opposed to just one variable. We're going to use two. So with that in mind, let's get started. We can read them carefully. The sum of two numbers is 56. Well, we'll let x equal one number, y equal the other number, so the sum of two numbers is 56. Their difference, again indicating subtraction, is 4. So the first number minus the second, the difference is 4. So these are our two equations. But how do we solve them? Well, let's set them up in standard form. And we'll note in this case, if we just put a line underneath them, that if we add them up, the y's cancel out. In a sense, they are eliminated, and we get 60. So we divide now both sides by 2. X equals 30. So we have one member of our ordered pair. So if x is 30, we now go into one of these equations, put the 30 where the x is, and there are different ways to do it. I chose to transpose the y to make it positive, transpose the 4 to make it negative, and I get y equals 26. And that's what we have. Okay, let's go on to the next one. Here we have the sum of two numbers. Again, our first number is x. Our second number is y. X plus y equals 44. And it looks like I've cut out some of the other. The second number, which is y, is 5 more than twice the first. So the second number is 5 more than twice the first. Sorry about that. I guess I cut that out. Okay. So again, we wonder what system should we use? Well, here, since we solve for y, let's use substitution. X plus y, but we know that y is 2x plus 5, and that will equal 44. We have substituted this value for where y was, and we get this. So I'm going to group like terms. I get 3x. I'm going to transpose my 5 to the other side. On the other side, it changes its sign, and I get 39. Now I will divide both sides by 3. I get x equals 13. That's my first member. And if I use either equation, I can put my 13 right there. I get 13 plus y now equals 44. I'm going to transpose the 13. On this side it becomes a negative, so y equals 31. So far we've used both methods for solving systems of linear equations. The addition method, which resulted in the elimination of the y's. The substitution method, again, which converted the y into some value of x. Now our next example, we should read it carefully. The difference between two numbers is 16. 5 times the smaller number is the same as 8 less than twice the larger. So find the numbers. Well, here it's important that you identify, as you set up your variables, one designation as the larger, which will be the x, and y as the smaller. So the difference between the two numbers is 16. That will be x minus y equals 16. 5 times the smaller number, which is the y, so 5 times y is the same, equals, as 8 less than twice the larger. Well, we said x was the larger, so twice the larger less x. There are your two equations. Now you might say, well, what method should we use? Well, this one's going to be a little more challenging. So let's set them up in standard form. Now here the 5y is good. We'll put that here, plus 5y. We have to bring this over, so this will be a negative 2x. Transpose that, that's going to equal negative 8. Now notice nothing is jumping out, but if we do some modifying of equations, this one's negative 2x, this one's a positive 1. So if I multiply each term in this equation by 2, something should happen. So let's do that. So we go 2x as we distribute minus 2y equals 32. Now this other one we're just going to copy. Negative 2x plus 5y equals a negative 8. So when I add them up, I get a 3y, these just cancel out, equals 24. Divide both sides now by 3. We get a positive y equals 8, which is what we have up here. So I can use any equation that I want. I have y is a 8. So this is going to be x minus 8 equals 16. I'm going to transpose the 8. On this side it becomes a positive 8 is 24. So the larger number is 24. The smaller number is 8. Now in number 4 says 2 records. Let's call the records R. and 3 tapes, called the tapes T, cost this much. So 2 records, 3 tapes, this much. Then 3 records and 2 tapes cost that much. So our 2 equations then are 2R plus 3T equals 31, and 3R plus 2T equals 29. Now here, substitution wouldn't work, and we're forced to use elimination. Now this is the thinking part. We want one of these to have a variable that will cancel out when we add them together. So we could choose either R or T. Let's choose the R. So if I multiply this by a 3, this will become 6R. If I multiply this by a -2, this will become a -6R, and these will cancel out. So 3 times 2R, 6R. 3 times 3T, a positive 9T. 3 times 31, 93. Now, -2 times 3R, a -6R. A -2 times a positive 2T, a -4T. A -2 times 29, a -58. Now when we add these up, we get 5T equals 35. We divide both sides by 5. T equals 7. So the price of the tapes are $7. But we now have to figure out what is the price of the records. So either equation, 2R plus 3, and we said the tapes are 7, substituting it there. So we get 2R, this is plus 20, how about a 31 here? 21 is what I was thinking of there. Okay, we're going to subtract 21 from both sides. We get 2R equals 10. R equals 5. And that's what we have. Okay. Now I can still remember from my high school algebra class, the first time we had a word problem. You know, read it, but then you want to define your variables. This was a very critical part. So let's read it. At school, 2 photography packages are available. Package A contains 1 class picture and 10 wallet-size pictures. So we're identifying the class picture as X and the wallet-size picture as Y. So our first equation then will be 1 class picture and 10 wallets. It's $19. So as we continue reading, and remember you should have read this before, that's what led you to set up your variables. package B contains 2 class pictures. There's our 2x and 15 wallet size for $31. So let's check this out. We have 1x plus 10y equals 19. 2x plus 15y equals 31. Now you could use substitution here, but we'll use elimination. We're going to modify equation 1. And remember, it's always a good idea to number your equations. You know what you're talking about. We're going to multiply this equation by, how about a -2? That'll let these cancel out. So we get a -2x, a -20y, and a -38. And this stays the same. We put our line, and we add them up. We have a -5y now equals a -7. So we're going to divide both sides by a -5. And we get y equals 1.40. It's okay for decimals because we're going to be dealing in dollars here. Now, we then put this value into our other equation. I'll use the original first equation, 1x plus 10 times y. Y is 140. So that's going to be x plus 14 equals 19. We're going to subtract 14 from both sides, and we get x is 5. So the class picture is $5, and each wallet is $1.40. A tad expensive, but I guess that's what they have. Now in our next example, we speak of a broker investing this amount of money in 2 different stocks. One will earn 9%, the other will earn 6%. And it will give this much interest. So we want to divide 4,500 into 2 parts. Well, let's say the part at 9% will be the x. No, it looks like I put it there as the y up here, and the 6% as the x. So this is the 6% plus the amount at 9% will equal this. And then 6% of the x, 9% of the y, gives you this much interest. Well, as we look at this, the more obvious way of doing it would be by substitution. We're going to say x equals 4,500 minus y. But first we're going to get rid of our decimals by multiplying every term by 100. So now we get 6x. We're going to put in our substitution for the x. We say x equals this, so that's where we're putting the x. Now we're going to multiply through. So as we do the multiplication, we get this, negative 6y plus 9y equals this. I group my like terms. I get a 3y here. Transpose that, subtract it, I get 9,000. Divide both sides by 3. I get y equals 3,000. So I will have 3,000 at 9%. And if I subtract 3,000 from 4,500, I get 1,500 at 6%. Now, had I switched the letters around like I started to do, they would have worked out just the same. You define something, and then when the algebra works and you do the computation, you get what each letter is defined as. The wonders of algebra. Okay, this is already just under 22 minutes. So my other explanation of all of the formulas, when you show the work, it takes more time, but hopefully this will be useful for you.